Wow, Christmas is really soon. Okay, modules. Machines are connected with cables. Cables are connected to modules. Modules communicate with pulses. If it was ignored. Hi, Rupert. Welcome to the stream. Off, load, flip. Each of their connected input modules. Oh man. It is very messy. Okay, so order they are sent. So every module has a queue of pulses. Okay, that's fine. Actually, okay, so having read this problem, I'm not sure I have a 100% clear understanding of the problem, like how these modules work. So each module can send, modules. They get a signal, they will send a signal to their other modules. If I send two things, and then the first thing sends it two more things, then this stuff, where is it? This stuff says that the second thing sent by the first thing should be handled first. But if the first and second thing both send two more pulses, I don't know what order they end up in. And maybe they just won't happen. Anyway. Yeah, if I were really going for speed, I would kind of just go for possible. Actually, I guess we should sort of see if the problem statement, how this works. Yeah, so yeah, it sort of feels like what we're doing is we have a global queue of all pulses that are in flight, and we handle the first pulse in that queue. Anything that produces gets appended to the end of the queue, and so on. And so we're just, it seems fine to do. Okay. So interesting. Let's see. So each of their connected input modules. And this is also a bunch of state that's not even really easily localized to each module, but I think we can work with that. So what we're going to do, okay. So what we're going to do, at the end, we're going to send a pulse, a low pulse to the pulse. False for low. Let's sketch this out. I'm not even totally sure what this is. Let's write this code. So no, while we have pulses in flight, name height. It's terrible. That's how I'm going to think about it. High or low is height. And what are the possibilities? What do we need to do here? So do we need to make a class? Oh boy. Let's do it. So what did I choose? There is a flip-flop. So flip-flop modules, when they get a signal that's high, you ignore it. Oh, I see. We need tests. What are we going to do here? So we're going to return a list of outward pulses. A list of strings, so I remember what it is. We'll figure out what it is later. And then we're gonna say, what do you say here? If the flip-flop receives, it matches the state that we are now in. So wow, very object-oriented. Bit redundant. It's not a big deal. And this part is the one where this is interesting. Self dot. This one doesn't have state, but this has this. It recalls each conjunction module remembers the most recent pulse from each input. So we're going to map input module name to the most recently received signal. It defaults to false here. Oh, okay, that's not gonna work because we need to know which inputs. That's gonna be a bit more work. Because then we can't build this sort of thing one by one. That's fine. I'm gonna store all this data. for both of these, just in case we'll need them later, and it's simpler this way. So we'll need to do one pass to prepare every module type. And every module's inputs and outputs. And then we're going to go through again and materialize everything. That's going to be the plan. So actually, in fact, we know what this should be. So assumes false for. We don't need to, whatever, okay, we don't need to store sources, it looks like, but so if we member high signal for every input, we're going to emit a low pulse for everything. This is not the right way to do it. We're gonna do that. Cool. Okay. So what we're gonna have to materialize. Actually, we can do it incrementally. It's easier this way. Is it? Let's write the input parsing as well. Yeah, lots of details about how exactly to get this information into the right form so that we can write the code we want to. So I don't know the right answer. Oh, I see. There is an implementation for that. Man, it would be so nice if we didn't have to know all the sources on initialization. Okay, what if we don't do this? We're going to go back to this, and we're going to check at runtime. Whether every source has the right input. This is very janky. Which one was which one again? Percent is flip-flop. Yeah, you know, in hindsight, and it makes sense that the and sign is the conjunction. Okay, this is pretty messy code, but we'll roll with it. So we're just going to do 2 passes, and on the second pass, we're going to plug all the oh, wait, we need to get the right name, and then we're going to do the second pass thing to put all the sources in, and Haskell. So, solving this in chat says. Okay, so yeah, I don't think I need a hint bound interpretation. I could be wrong, but if it is, I'll debug it. Haskell doesn't like multiple state. Yeah, this is a very mutable, like, definitely using the full range of Python here, but I can certainly, I mean, you just need to do the transformation in passes of data rather than, like, rebuild the entire data structure each pass. I don't think it would be, it doesn't seem fundamentally harder in my head, but that's not exactly what this stream is about, so I guess we'll see what happens. Okay, let's see if we've gotten it to the point where we can actually do something. So, oh, we need a source as well. Okay, that's fine. Okay. So we're gonna do that. Do people know their own names? That's fine, we can add it later. Source dest receive check the source. Why does this not work? I think the type is just, what's wrong here? This looks fine. We can always try it. So, I see. Okay, so we need a, and what else? We need to say how many pulses get sent the result. So that includes its own pulse. So, oh, and we need to send 1,000 of these pulses. So we're gonna start with this. I deleted the, why did I do that? I have not. This is just counting. Okay, it didn't work. Oh, why is there a space? That's not good. Oh, that's not what I want to split by. Space. Excellent. Okay, so there are modules we're not finding. Let's see if this works. It doesn't work. Why is there still a space? Oh, I still didn't split. I needed both passes. That's why it's bad. We have the right answer for the sample. We still have a key error on the one. So on the actual input, so Rx. Let's take a look. Yeah. Let's take a look at what is going on here, right? So Rx. Oh, okay. There is in fact no Rx input rule. Is that allowed? I mean, I guess it must be. Oh, am I searching for this? Yeah. Let me just make sure that if I have to do anything about that. Okay, on-site module. Okay, that's fine. Well, we'll just sort of brute force consume those signals. And we'll submit, and it was correct. Okay. Oh boy, it's this one. boy. Okay. So this might not work. If okay, this is just sort of doing it, and there's a pretty reasonable chance that this just won't work because it's some thing we have to reverse engineer. That's cute. I mean, we should let it run though. Actually, like, what is probably happening? What is like? This is probably an adder, and then we're doing some exponential stuff. So that would be my total blind guess as to like what the shape of this problem would suggest. But like we have like these things seem roughly like they should be implementing like a carry adder like you do in basic electronics class, and it's just adding one repeatedly to some large binary number. So the number of button presses we need is exponential. So, but how will we investigate this structure? Or is there a bug? There's no sample input for this one. Or there's no sample output for the input, so we're on our own. Cool. Oh, thanks for the follow. Okay, what are we going to do here? So it's, yeah, I don't know what they, well, let's get a little more visibility in here. So I guess taking a tiny look at what's going on here, right? So Rx gets sent to CX, and CS is, okay, I guess something else, it could, this might be another Chinese remainder theorem kind of thing, where there's some components and each thing is independently sending a signal only when like, you know, the every 37th cycle or something like that. And then so the fast way to do this is multiply, figure out these 4 separate modules and add them together. Again, I'm just complete blind guessing, but so we know that there are CS is the only input to Rx, and so we need CX or CS to send a low pulse, which means that KH, LZ, TG, and HN all need to send. Oh, there are a lot of these guys. All need to send a high input. Sort of, I'm going to assume this will not actually finish. Okay. So that looks roughly like we expect, but let's see if there's a pattern. Okay. Does this look like Chinese remainder theorem. There's a solid chance. You need to be off by 1. Let's take a look, shall we? That's what I want to do. We just grab a slice in the middle. It doesn't matter. You know, okay, people want to see me do this, so I'm going to do it. Okay, so what are these numbers? That's not how this goes. I want to get... What? Why is typing new list so hard? What is this type error? Can't index. Oh, it's words. Anyway, I'm going to look at this data and look at all the first numbers and then see if they're like an arithmetic sequence or something. What's this? Yeah, okay. That's pretty compelling evidence. Let's try the other ones. Cool. Okay. In fact, are these all multiples of the number? What is 561,819 mod? Where are we? 4013. Okay. Yeah. So we just. I guess we're LCMing these things. Do I have an LCM? I don't have an LCM. I bet they're all just primes. They're all primes. Cool. I'm gonna submit this answer. Okay. I don't actually know what any of the internals in the network are doing, to be quite honest, but that was just extraordinary. Guessing. I like guessing. I don't know what to say. I like... All right. Should I... Let's see. Is there anything I wanted to comment on here? I feel like I went to going a little fast again. Anyways, so... I wrote some very messy code to get the text into these like tiny classes that I built that capture which of the behaviors each of the modules have, as well as their state. And I forget where I read this, but there's this great blog post about how like classes, like how you decide when you should use classes and not just functions. Is that classes should usually have like both state to keep track of and behavior that's different from each other. And these have internal state and different behavior. And we want to switch between doing one of these depending on the character in a very unified way. So that's useful to know. And so this code sort of, the annoying thing here was that I need each module to know its list of all its inputs as well as the list of all its outputs. And you can't know a module's inputs just from reading the single line where it's declared. So you need to do well, there's several ways to do this, but I just sort of did a very lazy to-pass method. So I construct the type and destinations and then append the sources in. And this constructor input is pretty ugly, but least effort given everything else I've written before. And this, at that point, the signal passing code is actually super simple. So it's good. The rest is just to keep track of the info and the problem asks for. This didn't end up working. We just sort of shotgunned our way through looking at looking at the structure of the input, making an educated guess about what that structure looks like, realizing I really should figure out where to put an LCM function. It's kind of embarrassing that I don't have an LCM function ready to call. But using engineer's induction on the inputs that we got to the modules that are right before the RX module we care about, and guessing that the pattern would hold forever. Okay. Engineer's induction. That's the phrase. Day 21. "64 steps. Seems like a pretty solid where's the center of this? Do we have to find the center? Oh, there's an S. Okay. So S is a garden plot. Okay, I'll just... let's roll. Okay, so we're going to put the start location, and then we're going to repeatedly take the list of all positions that the gnome could be at, and then return the set of positions, next positions that the gnome could be at. And this is gonna be a set. We're gonna do that. Do I have a function now that I think about this? I had this function written, and then there have definitely been like multiple opportunities when I could have used this function in the past days, but I've forgotten all the stuff I prepared for speed. But this just takes a spot and gives you the four adjacent things as tuples, where they're actually things, they're V objects, which are my own vectorized tuple-ish thing that just vectorizes arithmetic operations, but it's not actually important here. Anyway. There's a function for this too. Yeah, just gonna do it. I'm feeling lazy. Okay, it's not 0. I was considering just submitting it, but it's not correct. Okay. Am I doing this right? Yeah, dots. Okay. What is wrong here? If it's possible that I'm not finding the star or something because I'm bad. Nope, it's 65, 65. It's a sensible place. Okay. It's actually just about the right place for you to not hit the edge. Okay, so what else is wrong? It's probably this. No, that's fine. Wait, what am I writing? This is totally wrong. Okay. Oh, we have some big numbers. There we go. There's the day 21 advent of code. All right. So this thing gets infinitely tiled. We have to traverse a much larger set of places. This number isn't huge. We could run this many steps. We just can't. We just can't run this many steps squared. Okay, so what do we know about it? So right away, either by inspection or thinking about it, we know that parity forces the elf to always be on a checkerboard, like one checkerboard color. If you color the grid with a checkerboard color, and if you take odd number of steps, it'll be on one color. If you take an even number of steps, it'll be on another color. But otherwise, that's with this many steps, most of the nearby grids to the center, the elf is absolutely going to be able to hit anything that is remotely close and has the right checkerboard color. So that's a thing. So I mean, the shortest path is obviously we should look at. So yeah, our thing is also has does look completely surrounded by dots. So the gnome is more or less going to be able to walk this many steps up, down, left, and right with like the epsilon shaved off every angle. Okay, but so it definitely looks like we're gonna have this like tile, right? Like each of these little black squares is gonna be a copy of the thing, and then we're gonna have some like huge diamond, more or less, of places the elf can go, and then we'll take the checkerboard things within that. But the stuff on the boundary is annoying. This is pretty annoying. This is, yeah, like I would not say that I've solved this problem yet. I still need to think about how to do it. How wide is this thing? Oh, it's 131. Okay. So that also means that each of these squares is at a different parity than the one next to it. So, or maybe let's say that the top left square of every tile is a different parity from the top left square of an adjacent tile. Is that what we're going to call these? This is a tile. I'll call this a tile. we have a lot of helper checkpoint things. Okay. And the good thing about this, I think, is that if we zoom in on like one of these tiles on the border, it's pretty clear that the optimal path to like any certain square here, if you want to go here, is first you go from the center to the corner of this tile, and then you find the path in from here. There's enough structure because these lines are on the edge of the tile are empty. You can say that. Which means actually that like most of these tiles are going to be the same. The number of squares, like this is the same Manhattan distance. This purple line to each of these corners is the same Manhattan distance. And so like the set of squares that you'll be able to visit in these things is identical. So that's useful. Like this should shape out to a complete solution, but it's still in my head. Like, it's the kind of thing I don't want to implement yet because it's very risky. Basically, there's just a ton of like if I have to write this code 4 times for I love the colors for each of the 4 edges, it's bad. But instead, I could do something like for every tile, I kind of just need to know what the Manhattan distance from or traveling distance from here to like each of the 4 corners is. And that's oh yeah, I forgot to also mention that like the stuff here is like there might be 8 cases in total, which is going to be an extraordinary pain. But if and I think this is true, I'm not confident, but as long as it's true that every row and column, other than the ones on the edge, have at least one marker, I'd like pretty sure it's going to be true for every single tile that the optimal route to get there from the center is to go to one of the first travel to one of the corners and then find the middle path instead of it. Okay, so what we can do, we can write a subroutine. So we can write a subroutine that or at least think about this still. Let's write a subroutine that takes the distance from these four corners and calculates, how many. So we're gonna take a subroutine that give it like four numbers, and then it calculates the visitable squares in that tile, or the number of them, given like that many steps from each of these corners. Also, I need to be right back. Let's see if these like be right back screens I wrote like a year ago work. What is this be right back image? Oh, it's a crossword. That's pretty funny. Hello. I'm not sure this is actually a new be right back screen, but it might be the first time I'm showing it. I am back. Okay. Okay, so we have an idea. So we're gonna write a subroutine that we're gonna give it four numbers, which is like the distance to that to consider from each of the four corners, and it's going to give us the set of spaces that you can reach from those four corners. Actually, it should just be a square and the set, and then we can union the set. But this should work, so it's not. I think I'm still going to. I can't see a way to deal with the like 8 orange areas of this diagram equally, like without duplicating a little bit of code or thinking about it. But it should become pretty similar. Let's just see if we can get it to. Okay. And to simulate tiling, we're going to use Pythons. We'll just mod it. So this will tile the grid, and we want this because we want some distances. Oh boy, this is pretty finicky. Okay, I'm gonna keep sort of breaking down my plan. New page. No, I want a new. What do I want? Button I want. That's not the button I want, but it works. We're gonna look at this middle 9x9 tile, right? And I'm gonna calculate the distance to like each of these corners or something. And that's gonna be useful because that's a bad example, but let's take like this one, like the right one. If I calculate the shortest path of these guys, and the ones that this and this are like not that obvious. At least I know that like each of these is just this plus like this distance, and so this gives me a formula for the distances for everything in that line or that quadrant. Is there a simpler way to do this? I think it has to look something like this. But the point is that every tile from in this arrow, once I have the distances from here to these 4 points, I can O of 1 calculate the distance I want for every tile in that direction, and likewise for like everything in like this entire quadrant, so on and so on. And let's say I do that. Then what I'm going to do next, I'm going to go travel along each ray. I could walk them linearly. It's like not disastrous. That's the end is like actually tolerable until I all this, and I still have to watch out because the number of things I can visit in this tile are different from the number of things I can visit in this tile because of parity. Oh man. Oh yeah, so I still need to care about parity when I do any quadrant. I'm gonna think a little harder to see if there's. I mean, an advantage of the actually 1/3 no, yeah, like advantage of the parity thing is that like I know I don't need to do any pathfinding to know the total number of visitable squares in this domino, for example, because uh, every square that I can't visit in this, because the n is large enough, every square that I can't visit here, I can visit here, and vice versa, as long as it's not blocked, as long as it's an empty space on the plot. But that's not quite enough. Okay, so I think we're just going to. Oh boy. Oh boy. Actually, is this number too large to do an n squared thing? What is this? It's 200,000. I like 200,000 squared is not disastrous, and it's like a half a factor off of that. So maybe the right way to actually not think about these orange things is just like I'm gonna draw a big square of tiles. I'm gonna check every single tile in here, and I need to do that in O of 1 per tile, at least amortized. But it might be fine. Okay, we're gonna do that. Alright, let me make sure I understand. This is the subroutine I'm gonna try. No, the distance is to travel. I want to solve one tile. So I'm gonna do. Right, I'm gonna write some code before I stop things. I have all these functions in my head and they don't quite fit how I want them to. It's very sad. I'm gonna catch this. No, I don't want to do that actually. Do you want to do that? 20? It'll be large. It's not outrageous. We'll see if this might be disastrous. Okay, but it's fine. I guess I need to think about the sort of diameter. Top left, top right. I should just do this, right? So ease the suffering thinking about lengths. That's wrong. All in one tile. And what we're going to do is that the key thing is if it's none, we're going to say that sort of means that everything is visitable. Oh no, but that's still... Okay, we're gonna set or number, set of positions or. Okay. Do some awful return types, but that's fine. So if it's an int, we know it's true. Like, okay. Okay. Very nice. Can do that. Okay. Now. Man. We should. We need to do it. We should do it BFS. I'm just trying to not have to write this transition code more than once. I'm trying to think of like one thing that will encapsulate everything I want to do with these distances in the grid. Jeez. I think the answer is yeah, I don't. Def distance source. That's yeah, I think that's what I want. Okay, so we're gonna do here. So just one position. And what's the limit? Do a sort of do that. You can do a sort of 2Q BFS as classically done. So everything in the queue is that. Put that here. And yeah, BFS and parity. We have to always keep think about parity. Nope, we're not doing this here. Wait, no, what? Curtis. Okay, we got that. We're gonna cast this too. I didn't import it here yet. Do that. But I think this is coming together. What is good distance? We'll just say like 300 or something stupid. That's fine. So what am I doing here? No. Thought I was going to do that. Desert this. Man, this is really tricky. I'm not having trouble localizing what I want to do, but so we have a function it's just gonna, I'm gonna give it a position. It's gonna find all the, it's gonna pre-compute a map of the walking distances from that location into everywhere in the tile or just anywhere. And we're usually going to call it with the corners. And here we're going to pass usually a corner, and we're going to ask if we want to visit every tile that's distance this much from that corner. Like, which tiles could it visit? And to do that, basically the distance there has to be less than, so not this, and the parity has to be equal. And there's an exception where if we can cover every square in that tile that has the right parity, then we're just gonna note that fact in the return value, because we're sort of saying if you try to approach this from a different angle, it's not going to help. You already visited everything in that tile. Okay, so that's like something. Man. Okay. And everything is, I'm going to be calling a lot of these functions with repeated arguments, so I have functors caches sprinkled everywhere. And now to write the whole grid. God, this is still very annoying. I want to travel like to the adjacent tiles. Let me see if this runs. I feel like this is not even gonna run. Just at this point, there's just gotta be bugs. Excuse me. Okay, yeah, that's 1,000 isn't that large. Seriously? What's going on? I see. No, I'm doing something very wrong somehow. How is it so bad? I'm so washed up I can't write a BFS, huh? No, it looks... Oh, no, it is fine. It is that bad. It is quadrat. It is... Yeah, okay, it is bad. Wait, what? No, does that make sense? Man. I'm pretty sure there's something really wrong. No, this shouldn't matter. I mean, the only thing that this... Wait, I don't think I understand why this is. No, I'm done this still. Oh, I'm not to do. Oh, duh. Okay, these are now sets. It's exploding. Okay. Oh, that sucks. Wait, really? At some point I forgot to do. Syndrome map 0, 0. I feel like I've written this bug before. There's no way. It's definitely close up for 1,000. Oh wait, I'm just writing all the awful bugs. Okay, getting closer. No, this should just be. This might just be 0. Why is it still print? What is it printing? Come on. Okay. Am I mean, is this? You know, now that I. What does this mean for me? Is this surprising? Not really. The corner, yeah. Which means there is, like, the Manhattan distance to each of the corners equals the, like, number of steps. Like there exists paths that don't pass through any hashes. So it's kind of anticlimactic in the sense that, like, okay, so but what does this mean? This means that 300 is well more than we need. Like, it's not, these tiles aren't very messy. There's like no. Now that I think about it. Can we? It does the fact that these, you can often just sort of greedily walk from a corner to any place you want, and it's almost just usually equal to the Manhattan distance. Is that used? It's not always true, right? Like this tile right here, you can't go to the top left corner by the Manhattan distance. There's some structures. It's definitely, they're rare, but yeah, like this one to the top, to the bottom right corner is going to be a bit of a mess. Yeah, you do need to be pathfinding, but okay. But if it's just that, so I guess what we want to do is this, right? Like, no, I didn't. I do want. Oh man, 130 plus. What's the number again? Plus 130. Maybe plus 130. What is it's like, oh, I found her. So let's see if this works. Let's write some code that won't work. Okay, what's the range we need to go through? That. I think you like add one or something. I don't know. It's okay if our tile is like one. It's like a negligible. It's not an O of difference. So I'm just gonna scan a really big. Pretty big set of tiles. I'm going to see if this pseudocode is, it's like, I think it's like within 1 or 2 orders of magnitude of where we want to be, but that's probably not going to be enough. But I still want to see if it is like correct on, what do I do here? So ref tile is that thing? Signum? No. There's definitely some people. I read the Stack Overflow question. Somebody complained that Python didn't have this. They're like, just write this instead. It's fine. Basically, for any tile, I want to figure out the like nearby tile that is like this tile is like sort of uses this tile as its reference tile. This tile uses this tile as its reference tile. The one that's like in the middle 3x3. And then we know that it's a tuple. I guess I could also, if this is less than, so if we want to see how many tiles in this tile, the tile with offset tile R and tile C from the center, how many things we can visit there. We know the distance to its corners equals the distance to these, the distance to this reference tile's corners plus the side tile movements for each like whole tile you have to travel. And then that's the remaining. So this is the remaining distance you can travel once you get to a corner of that tile. And there's no way this works. This is actually impossible. But it's okay. Let's see if we can. We should really check out this like. This has to like example. Where's a good? Is this gonna work on the sample input? Oh wait. Oops. Wait, what? Oh no, that's fine. Wait, why is it not using? Why did I do the thing again where I like save the same input to the? Is that the right answer? That is the right answer for the sample input for a small number. That's pretty cool. So we should try it with that. See if we're doing the right thing. It's going to be slow. This is probably already obviously too slow. Yeah, we are sort of already magnitude off, but okay, we're closing in on the answer we want because why is this hard? Or why? Oh yeah, this is the whole row. It's just doing the row. Okay, so okay, actually no, we are many orders of magnitude off from where we need to be, but that's okay. Also, wait, this radius. Oh, I see. Oh, sorry. We're using the sample input. It's actually faster on the real input because the radius is smaller. Okay. So, yeah. I think we have to do the math. We gotta do the math. We gotta draw the. We gotta do that. We gotta do the 8 things. Okay, I gotta refine this. Okay, so. I'm gonna do this. What? Oh, it's the wrong Python. Python 3. Okay. Let's see if I did the math right, or the radius is like off by 1 or something. Okay, that's. Oh. Okay. So it's the two parity things. Thing we care about is. Okay, I was off by 1 at least. Okay. And if we add 1, this should be. Oh no. Okay, that's fine. Cool. If I add 2 here. Okay. So at yeah, it's roughly, this is roughly how I expect the problem to be shaped. Okay, so at top, we have a 260. Yeah. We need more than that. Here it's 987 6846. And is this enough information to? No, I'm gonna do this all the way. I think it's just less error prone this way. So on the right we have 2076. On the left we have 2041. Actually, it doesn't. This is like roughly. I know I need. Well, I should double check that I'm thinking about this correctly. But okay, so this is 1. No, this is. Okay, so I don't need to think about orientation. I can already just calculate the right coefficient for all the things on the border. Just do this. I'll subtract. Am I gonna be sad if I subtract 1 and then forget? I'm gonna call this a different word. Oh my god, what's a different word from radius? Stretch, I don't know. Extent, that's better. So I just don't subtract 1 all the time. Okay, so 1 of each, that's the edges. And then the one next to it needs to be multiplied by how many are there here? This is TR, this is T minus TE, so this is TE by TE, so that's going to be tile extent, that, and then the one less than that's gonna get one less than that as well. I shouldn't copy that. And the rest is just all the parity stuff in the middle. And that's the one that's like, do think about. But it's like a square. So this is this square. Move this down. The ones of this size. Okay, so here. Let's make sure this is true, right? So 0 tile radius minus, no, what, this is minus t. This should be the same as everything. Okay, so that, this is t, or no, super bottom, t minus 1. So this is a square. It's the outline of a square. I'm not going to draw the rest of the square. Imagine the square. So this square has side t minus 1. Is that true? This goes, no, it's te itself, because this coordinate is t minus 1, and it goes 0, and it's fence post, so it includes it. So I would multiply te minus tile extent minus 1, 0 times tile extent squared, and then the one past it by 1 minus. Okay, and like, I would just submit this because, like, if it's wrong, like, which as you can see it is, I need more than a minute to debug anyway. Okay. Cool. Let's check this against. Oh, wow. Dang, it's right on the sample input, but wrong on the real one. That's all right. No easy debugging for me. Okay. But we're close. I know if I fix the bug. We're close. We must be close. I guess we can try all the other. See if there's anything. Okay, that's wrong. That's cool. So why is it wrong on 500 and not any bigger numbers? Maybe let's see if there's a. Okay, 100 is wrong. I guess let's also do that. See if that's the right, that proves the right answer, but this answer doesn't work. Okay, that is the wrong. Okay, so we have an example, and I think if we go smaller, it's might stop being like similar to the real problem. So I'm gonna stick with this one. Okay, so why is It's wrong. And why is this producing the right answer? I guess I will. What we can do is. See if this is in fact finding the like repeated things I want it to. Oh, the one. I think this tile. That's a bad example. Like this tile isn't necessarily complete, so I need to do that one too. Wait, did I not? Well, that's weird, right? I guess we can like figure it out. Actually, wait, hold on. Let me just figure it. This makes sense. So that's the checkerboard. There's probably some collisions. Man. Oh no, I got the wrong number. Okay. Okay, so it's not this number. Oh wait, I forgot I had to disable this. Nope, not what I want to do. Okay. Typing is hard. Just make sure this is in fact true. Okay. So I thought that -1. This would be equal to this just look fine, okay? So yeah, that checked all the sides. Oh no. Okay. That square seems fine. These should all be the same, right? Yeah, okay. And yeah. there could be some more subtle bug with my reasoning so far. Could be a typo with one of these pluses and minuses. Pretty risky. No, yeah, what am I doing? I should be debugging on the 100 case. It's very silly. It's how I... Oh. I will... So, it's fine. Oh. No, that's fine. Okay, this is just... What happened to this? It's totally wrong now. Oh, it's too small, right? Wait. Wait, now I'm confusing myself. Wasn't I able to get the right answer for this before? So now this and that are both have the wrong answer. And I don't know why. It could be, yeah, okay, yeah. The reason there's this code doesn't fully handle the. It should roughly handle it, but it could be like off by one in terms of like where the edges get drawn or something. I thought there was an example where two answers gave. Doesn't work. Man, did I change something that made this stop working? What did I break? What the heck? Now everything is giving wrong answers. I thought I had... Did I delete it? What happened? I'm pretty confused. I thought I had this working on sample input. Now it's gone. I didn't change anything. What could have changed? What should I change? Oh no, it's because I changed this, right? What is this function? What is this? Oh, I see. Wait. What? I don't know how my own. Oh, I understand. Do I understand? Serves me right for using my library without knowing what the arguments do. Okay, so that is the right sample input. All right, yeah, the problem. What's the fancy one? That one's fine, but it's bad for like 100 or something. Okay. And what's the right thing here? I think I'm supposed to. So does that censor the problem? Okay, it does. Where are you printing out? It's just the radius loop. It's just the row loop. I have negative rows. That's what it is. Okay, so why do these not match up? I guess what we need to do. I just want to. Anymore. Okay, so what doesn't match up? Interesting. 35 is totally off. And we're a little off. Interesting. I get. Is it I'm kind of worried that like the bug that there's like a separate bug in this test case that doesn't actually apply to the test case I want to solve because the way the line gets drawn is like off by one. It cuts through the tiles in a different way, and that's like not terribly interesting, but I'll fiddle with it. This T. I see. Yeah. So this in this one, this for this input, the input cuts through like two of these, two of the like northernmost and southernmost and so on. Okay, so we can try to make it work. But it's just very like, I don't think that actually happens for the one we care about. But if we do that, the 3 will be here. This should be safe. Like, this kind of thing should be safe to do. So now we just need to do these guys. I'll do that. Nope, I don't do that either, this thing. 2. Okay, they agree now. And it's kind of weird that delete this. I don't actually know what the bug this would have been is. It's the same answer as before. So that's bad. Okay. Oh boy. I mean, we can try different distances. See if we can find another bug, but that's big enough to care. Okay, so we're out of test cases to test on. But whatever the bug is, it's more subtle than that. That's not good. What bugs could happen? Is 300 too small? Why is this 300? I thought no, is that suspicious? I mean, we can try it. Oh, I forgot to. It'd be really weird if this changes. Did that change the answer? Nope, it didn't change the answer. Okay. I see that I am not going to finish before today's problem publishes, which is maybe a little awkward. Oh boy. Yeah, lacking any great ideas, I'm just gonna read the code and think about it for a bit. It's surely not that you can get here, right? Actually, $987. It's not. Is it a parity issue? This is odd. Like, is there anything I might not be handling correctly because the number is odd? Hmm. I don't see anything. Well, I guess. Very mysterious. Just double check what my numbers are printing, and if this like makes sense. So I'm not. Yeah, all this was not this was added all to handle the like other test cases that sample hit on, but the rest of these seem fine. So that's pretty weird. I mean, I think there must be some deeper issue with my code in this case. So is it false? Oh, it is. Wait. I did make an assumption at the beginning when I approached this problem that you couldn't, like, I was hoping that when you go from here to here that there wouldn't be a short path like this, that you'd have to go out your corner and then this way and this way, but that could just be false. Forgot about that assumption. So it seems so unlikely, but it is. Do I have to transpose? No, I don't. Let's investigate this a little bit. Nope, I can't type. I don't want to count. Okay, so it's not true that there are any columns. I assumed. Oh. I see, the center column. Oh, the center column is actually empty. Man. Oh, wait, is the center row empty? Wait, I might just be really dumb in this. Haha. Oh. Now I feel really dumb. This. I see, okay. Yeah. That's the issue. Does this make it a lot easier or a lot harder? I made a well assumption at the beginning of the problem that every row and column had at least one hash, which changes the calculations quite a bit. Like it simplified the problem, but it turns out the problem was simple in a different way. Because you can always just go straight north, south, east, or west to the tile. And then figure out what to do from there. Okay. In that case, well, the only things we need to fix. Can we fix this by changing the corners to... Can't save this. What am I writing? That's what I want to write. I wonder if this just somehow magically works. Should I submit this? It's pretty close. It's the right shaped answer. Okay. Well, that was fun. And this I cannot test this on the sample input because it's different. What are the things to check? First, are these coordinates correct? I think they are. Okay. Oh, what if we can just do all of these corners, right? Then that'll work. Slower, but why would this be correct? Let me think about it. So yeah, the point is the same, right? The point is first you travel to a reference tile corner, then you travel to the correct tiles corner, which you can do with the Manhattan distance between those corners. Finally, you travel to the tile you care about. Okay, so let's see. I probably timed out. Okay. Yeah. Read the input. For once, I was not in sync with what the problem was asking me to do, or like what simplifications were valid. It's unlucky. There is a live day, I suppose, but I should just do B22. Man. Sand has fallen. Bricks. We were okay. We are going to 3 dimensions. Very nice. Oh my god, there's this whole diagram. Okay, so Jesus. Okay. First drop them. Okay. These numbers are pretty small, so we're just gonna sort of move it one by one. It's fine. Yeah, I'm gonna iterate over all the bricks and move them once in the Z direction, if they don't overlap with anything else. It's perfect 1, so you decrease Z if possible. Okay. Okay. many bricks do I have? Okay, there's... This might be a little bit slow. Let me think. So what am I gonna do? I'm gonna iterate over every brick, and then see if I can move it down. When I do that, I'm gonna iterate over every other brick to see whether moving it down would collide with it. And I'm gonna repeat this like 100 times or something. That's kind of slow, actually. I think it will still be fine. No, I'm gonna spend like a minute to see if there's a way to deal with this in a very simple way, or make it like more efficient very easily. These bricks, I mean, these bricks aren't. The X and Y are all very small, so. We could probably sort them by like Z and then drop them one by one or something. That's probably fine. Well, yeah, we'll do that instead. Okay. This might not be sustainable, but we're going to sort them by the lowest Z they have. And then we're going to drop them. These are lists. Yep, so we're just going to mutate it. This is pretty risky. No, I'm not gonna, I can't deal with this. Actually, does it say that they're always two coordinates? Yeah, unclear. Okay, whatever. So X2. We're gonna use we're gonna figure out where this brick falls, right? We've sorted the bricks from bottom to top just by a very naive bottom edge, and that should be enough to ensure that they drop. Yeah, any two bricks that are on top of each other will be sorted in the correct order in this sort. So you should need to drop them in that order. Height is support. So what's the tallest thing that would be under this brick where it is? X, Y. Yes, that looks fine. And then Z1 and Z2 have to become sort of, they fall to 1 plus support. Okay, now I wish it's fine. guess we're doing this way. Is this correct? When the already equals support, we don't do any falling. Okay. Oh, and we set height, of course. Okay. I see. Okay, that's not quite enough. We need to figure out, I guess, equivalent to saying whether when we land this brick, whether it's load bearing, I guess. So we need to let's use IE. Full support. And so what is this exactly? Height and new. Okay, so this is the brick. So we're dropping this brick. This is the brick that it's going to land on, or this is the height that the brick's going to land on. There might be there could be one brick or more than one brick, or 0 bricks if it's on the floor that this brick is going to land on. So we need to figure out which of these, how many different supporters there are, I guess. So pretty janky, but this is fine. Probably, I don't think it's too slow. We're gonna take all the supporting bricks that hit that height, take their IDs. And we're gonna mark that this brick is supporting that location. Come on, it's fine, right? What am I doing? I'm not returning anything. The type's just wrong, it's fine. Won't worry about it. What is this code here? So if supporters, if there's exactly one supporter, then we mark it as, I sort of feel like the thing I'm running now is going to come back to bite me when I do part 2. I'm just destroying everything. Okay. And so So we have dropped every brick down, and then for every brick, if it is resting on exactly one other brick, we've marked that other brick as unsafe. So we just need to figure out which of those bricks is how many bricks are not unsafe. Could be safe. We choose. I mean, should I just submit it without testing? Sure, whatever. I did it. Okay. That's fine. This is actually just like pretty fine because all I need is this graph structure of saying okay, can I do this in one pass? Don't think. Wait, can I? So, basically, this is saying, so for every brick, if I disintegrate it, how many bricks would fall? And then sum that, which is equivalent to saying, like, for every brick, how many bricks would cause this brick to fall if disintegrated, and then sum that up. It's just double counting. So, we should be able to do it in one pass. We just need to figure out the right. So for this is going to be for this brick, how many things would cause me to fall? This is a default date. No, it's fine. Should I run this without submitting? Okay, shouldn't. But yeah, we can eliminate the. I'm gonna eliminate the ground case. Okay, it didn't work. Supporter. Okay, why does it not work? Also, these variable names are bad again. I say the word support, and half of these are the IDs, and half of these are heights, and it's very dangerous. But supporters are IDs for now. Okay, so why is this wrong? Why is there a key error? Oh wait, hold on. What? Oh no. No, that seems fine. Just figure what's going on. Shouldn't I set it here? Unsafe. Is there no? Yeah, so. Oh, I see. Because. Okay. Fine. Yeah, so this dictionary is supposed to contain, for every brick, how many other bricks would cause it to fall. Okay, so we can test. Oh, I see. This is wrong because if one brick disintegrates, that could cause two bricks to just like fall simultaneously, and then okay, so this doesn't work at all. Cool. Now I know that. I'll just cut minus it out. Okay, so we can't do it. We cannot do this in one pass. Cool. No, we can do it in one pass. We just have to. No, okay, no, that doesn't work. Maybe we. What is? So for every brick, when we drop it, we're going to. We know it's supporters. So then we can calculate like every support. The things that would cause us to fall are the things that would cause all of our supporters to fall. So let me name this thing. Would cause me to fall. Okay. If supporters brick, i.e. Do I have this thing? Yes. What? I thought I could filter this out. Oh, this is bad. Shadowing. I'm sort of okay. That wasn't the issue. What is the issue then? My code quality has significantly declined over the course of this month. Why is it -1? I literally filtered it out right here. Oh wait. No, I filtered out 1. I'm dumb. Okay. I see. No, so, there we go. Okay, so what did I just do? Yeah, oh my god, this code is terrible. Every brick, we have the code from before to drop these bricks one by one in increasing z order. When we drop it, we figure out which other bricks are supporting it. It could be 0 if it's on the floor. It could be 1. It could be more than 1. And the goal is to calculate which bricks, if disintegrated, would cause this brick to fall. This is a helper that I somehow remember I wrote, but it just makes it slightly easier to write. But the bricks that would cause me to fall are like this is everything is in this end that if I AND it with something, it gets something else. But the key is, so things that would cause me to fall, if I'm supported by one brick, that brick would cause me to fall if disintegrated. And any brick that causes all the bricks I am supported by to fall would cause me to fall. So we intersect all this together. And in the case where there's one supporter, this is just copying that supporter's dependencies and then adding that support itself. Okay, let's see. I guess I'm curious with the leaderboard. I'm not gonna do day 23 on stream probably, but I'm curious if it's filled up yet. It has not. Okay. But yeah, that's probably the penultimate stream for this year. I'll see anybody who's interested maybe on Christmas then. Goodbye, happy holidays.